So let's enter the ps command in order to see the processes that this user is running. We'll also use ps-l, which shows us the process ID, the parent process ID, and the priority, and the nice number. Notice that the parent process ID for the ps command is actually the process ID of the bash shell. Let's run ps-aux, and this will show us not only the user's processes, but the daemon processes as well. Let's pipe it into less, and you'll notice the first process that was started after the kernel process was started, remember kernel process has process ID of 0, is the init process with process ID of 1. And go ahead and hit the spacebar to go through each line and press Q to quit. Another way to view user and daemon processes is to type in ps-ef, and we'll pass that into less. In order to see a representation of the process tree with the parent and child processes, enter ps tree. So you'll see the system D process, the system daemon, started a number of processes. Now you can also use the -p option to display the process ID of each one of the processes. So go ahead and pipe that into less. And again, you'll see that has a process ID of 1 for the init process. And press Q to quit. Or the spacebar to page through each one of the lines or each page of the ps tree command. Now when we ran the who command and we ran pstree-p, we were running those commands in the foreground. If we want to run a command in the background, we have to follow the command with the ampersand. Any process that's running in the foreground means that additional processes have to wait until that process completes. Type in sleep 1000 ampersand, sleep 2000 ampersand, and sleep 3000 ampersand. In order to see the processes that are running in the background, you can enter jobs. And you'll see that there are job IDs. Now also notice there are process IDs. Process IDs are going to be unique to each system. Job IDs. So how can we stop these processes from executing? Well, go ahead and type in kill-L. And what this will do is this is going to let us know the different types of kill levels. Now kill-1 says a signal handout. SIG-init is a interruptible interrupt. There's also SIG-term, which is a software termination signal, and there is the untrappable kill-9 SIG-kill. Now what does trappable mean? Trappable means that a process could actually trap those interrupts, but with SIG-kill, the entire contents of the process are redirected to /dev/null. Now let's kill one of the processes with a weak kill signal, the kill-2, and we'll type in ps to list the processes. And you'll notice out here, I did kill-2 1438 because that was the process ID for one of the sleep commands. Now you'll notice it shows it's interrupted. If I do a kill-9, it's going to say killed. Now depending upon what version of Linux you're using, you may see a different message appear when you run kill-2 or kill-9. Based upon these options, you may see different types of messages. If you enter jobs, you'll see that there's still one job running in the background. Now there's yet another way to kill this process off, and that's to do a kill % and the job ID. So to stop this job from executing, we'll do kill %3 because that's the job ID. Again, this is for the job ID, not the process ID. Now you'll notice when we type in jobs, there's no longer any jobs running in the background. Let's again create some jobs in the background. We'll do sleep 5,000 ampersand and sleep 4,000 ampersand. Now let's bring one of these jobs to the foreground. We can do FG %1 with the job ID. Now once we're in the foreground, that means that no other jobs can run. If we want to send that job back to the background, we have to press Control Z, and that'll stop the job. And then we can send it to the background by doing BG %1, which is, again, the job ID. So we stop the job. That's not the same as killing it. It's just stopping it by pressing Control Z, and then we could send it to the background where it could run again. Another command which can be used to kill these jobs off is the kill all command. Now the kill all command will kill all jobs that have a specific starting process. Now if you wanted to kill all the jobs, no matter who the owner was, you would actually use sudo kill all. Again, let's do a long listing of the jobs by doing PS-LA. Now again, you'll see that there's a priority and a nice number. Let's do PS-AUX. And let's do PS-EF again. Now each job runs with a specific priority. Recall, the priority is used to determine the proportion of CPU cycles that are assigned to each particular process. Remember, the larger the priority number, the fewer cycles that process has. The nice number basically defines whether or not we'll take fewer cycles or whether we'll get or obtain more cycles. So let's actually enter the nice command, and you'll need to enter nice -n +20 and then sleep 1,000 ampersand. Now that'll set the value of the nice number. Now because we're being more nice, what that actually means is that you're running with lower priority. So now the priority is 99 and the nice number is 19. Now if we want to change the priority of a job, we can change a nice number by using the renice command. Now renice is going to take the process ID in and not the name of the process. So if we try to renice the process, the sleep process, that has process ID of 1466, you're going to see that it's permission denied. Because whereas we can become more nice by having a higher nice number, we can only become less nice, change our nice number to a lower number, by using sudo. That's also true of me setting the nice number. If I try to set the nice number, you'll notice that when I try to set it to -19, I'm not able to do that unless I enter sudo and run as a super user. Now you won't see this process running because it's being run by root and no longer by this user. Go ahead and press PS-L to again see the long listing of the processes we're running, and let's kill those sleep processes off. Now all the sleep process was actually doing was putting the system to sleep for a certain number of seconds. Let's take a look at the virtual directory, cd/proc. Now cd/proc only exists as long as the system is booted up. Inside of the proc directory, there are a number of folders, and each process has a folder associated with it. So if you look at the process ID for the bash shell, you'll see that it's listed here as well as the init process. So go ahead and do a cd to your process ID. And my process for the bash shell was 1391. Yours will be different. If I type in more CMD line, I can actually see what the name of the executable is. If I type in more limits, I can see how much CPU utilization is allowed, how many files can be opened, how much memory can be used. If you do more mounts, you can see any of the drives that are mounted on the file by this particular process. We can see how much input-output is occurring. We can see how much memory is being used. And there are other values that we can also examine. Next, let's take a look at the at command. The at command allows you to run a command one time in the future. A similar command is the batch command. The batch command, however, runs one time in the future when the CPU utilization is low. Now, when we enter at right now, we'll see that the command's not found. So we'll need to install that by doing sudo apt-get install at. So once you've installed it, in order to run a job, you can either specify some number of minutes from now by doing at now plus 5 min and put a list of any of the commands that you want to execute. Now on your system, it might also prompt you to specify what editor you want to use. You want to actually use the nano editor. Press Ctrl D once all the commands are input. Now you can also specify a particular time, such as at 11:50 a.m., or a particular time and date, such as at 1 p.m. on March 23rd. Now you can display the jobs in the at queue by pressing at Q and at -L. You can list the contents of the job by doing at C, or you can delete jobs by doing at -D or at RM with the job ID. Another way to run jobs, if you want to run multiple jobs, is to use cron tables or cron tabs. Type in crontab-L to list your current cron table. To edit the user cron table, enter crontab-E. Now this lets you specify the minute, hour, day of month, and day of week, and then the commands. Now you can also use run parts to say execute all the scripts in a particular directory. So let's run a job at 9 a.m. on the first day of the month, every month, and the day of the week we'll do 1 through 5. Now either 0 or 7 is Sunday, 1 is Monday, 5 is Friday, and 6 is Saturday. Now the asterisk that you see in there says run it for all occurrences. Now one other thing to consider is that the hours go from 0 to 23 in military time. Day of the month goes from 1 to 31, but of course if you had January 31st, that would run, but February 31st would not. You can also specify a series of times which you want to run this command. In this case, we want to run the command every hour at 0, 15, 30, and 24 minutes past the hour. And we want to run this on the first day of the month, and every day of the week. Now what happens if you enter 5 asterisks? What do you think the problem is with this command? Well, the problem is that the cron daemon, cron D, is going to check every single minute, because you put an asterisk in there, to run this command. Now, typically, this is not what you want to do. Now, just like the at daemon checks once every minute to see whether there's an at job to run, the cron daemon is continuing to check every minute to see if there are any cron jobs to be run. Now let's say that I wanted to run a command every 15 minutes. I'm going to do */15. I'll do a star for an hour to say every hour. First day of the month would be January, and the day of the week would be the first day of the week, which would be Monday. Now, again, to exit out of this, we'll press Ctrl-Z. I can do a crontab-L to list the cron tab, and if I decide I want to remove the user cron tab, I enter crontab-R. Now there's also a system cron table that's run as root. Go ahead and type in cat/etc/crontab. Now you'll see that there are jobs that run hourly, daily, weekly, and monthly. The hourly jobs run every hour, 17 minutes after the hour. The daily jobs run at 6:26 a.m. The weekly jobs run on Sunday at 6:47 a.m. And the monthly jobs run on the first day of the month at 6:52 a.m. Now notice that there's a run parts. With run parts, this actually says run all of the scripts in the directory, for instance, etc/hourly, cron.hourly, etc/cron.daily, etc/cron.weekly, and etc/cron.monthly. Go ahead and view the scripts that are in the cron daily. Go ahead and do ls/cron.daily and do -l, and you'll see that they are all executable scripts. And that's also true for the weekly, the monthly, and of course the hourly.